welcome to the Elvatech's YouTube channel. Today, we will explore an essential topic in XRF analysis, the matrix. What it is, how does it affect your results, and how can you handle its effectiveness? Stay with us to learn how Elvatech's analyzers simplify this complex process. The metric is the entire composition of your sample, not just the elements you're analyzing, but everything else present. For example, if you're testing iron and steel, the matrix includes carbon, chromium, nickel, and other elements. Why does this matter? The matrix can influence element signal, potentially distorting the results. Let's dive in and see how to address this. When X-ray interact with the sample, some elements may weaken or strengthen the signal of others. The phenomenon is called the matrix effect. Think of absorption like light passing through the dark glass. The darker the glass, the less light goes through. In analysis, a heavy matrix like lead can weaken the signals of lighter elements like the aluminum or iron. Enhancement, on the other hand, is like an echo in the large hall. The sound becomes louder as it bounces off the walls. In XRF, heavy elements like nickel can simplify the signals of lighter elements like an iron. In real-world application, matrix effect can lead to inaccuracies if not accounted for. For instance, in an alloy with the high concentration of heavy elements, the results for lighter elements might be understated. The best way to handle matrix effect is to use the analyzer that automatically corrects for them. The ProSpector 3 comes with the pre-confirmed calibration for various materials, making it easy to adjust for matrix effects. For instance, you can select the steel mode for analyzing steel or the aluminum mode for analyzing aluminum alloys. This ensures the matrix effects are considered for accurate results. Another effective approach is to measure multiple points on the sample and average the result. This is especially helpful for materials with an uneven surface or complex composition. Take stainless steel, for example. To accurately measure chromium and nickel content, you need to account for how they influence the signals of iron. Without this adjustment, your result might be misled. In aluminum alloys, elements like magnesium can absorb signals from other components. ProSpector 3 compensates for this automatically using its advanced calibrations. Multi-layer coatings are another challenge. For instance, when analyzing gold over copper, the copper can amplify the gold's signals. ProSpector 3 can handle these complexities seamlessly. Before starting the analysis, make sure your sample surface is clean and even. Dust or debris can cause inaccurate readings. Choose the correct mode for your material. And if you are unsure, our technical team is always here to help you set your own analyzer. Measure multiple points for complex samples, use the correct calibration, and regularly check your equipment settings. Elvatech analyzers are designed to handle matrix effect efficiently. ProSpector 3 uses the fundamental parameter method to automatically adjust the matrix influences, ensuring precise results. This technology makes it easy to analyze even the most complex materials without adding manual adjustment, saving your time and your effort. The matrix can significantly impact XRF analysis, but with the right tool, it's an easy challenge to overcome. ProSpector 3 handle matrix effect simple and reliable, helping you get accurate results every time. If you have any questions, feel free to reach out or leave a comment. Thank you for watching, and we'll see you in the next videos. Stay tuned and see you soon. Bye.